So, hey guys, so this is Oluwakemi here, and I will be showing you like I'll be constantly coming to record my front end development journey. So, so following this roadmap that I have on the screen, which is this front end. So the first thing I would like us to go through together is the what internet. Is the internet. So I've actually read about it, made findings, what is the internet. So I'll be we'll be checking what is inside the internet, how does the internet works, what is HTTP, what is the domain name, what is hosting, DNS and how it works, browser and how they work. So let's get started from what I've jotted and what I've been able to grab from, you know, from my reading for today. So let's go through what is internet. So I'll be making this very simple because for those out there that also want to start challenging themselves to maybe start something, maybe I think front end is the beginner aspect that somebody can just decide to start with. So let's go right into it. So what is the internet? So let's look at internet is let's look at the definition from here. What we have here, we said the We said the internet is a global network of computers connected together to each other, which communicate with a standardized set of protocols. So, what does that simple this thing mean? So, the internet is a huge network of network. So, imagine millions of computers now, millions of phones or servers, all connected like a giant, let's say giant, a spider web. So instead of wires everywhere, some connections are through cables. So some the cables can be under the ocean, some are in the satellites, and some are Wi-Fi signals. So imagine the internet as a giant web now, your spider web now, Spider-Man let's say it's the internet of a giant web of roads that connect different cities. So let's imagine our computer to be a city. So these roads allow cars. So let's we are like analyzing, like we are trying to break it down. So we are imagining our computer to be a city. So we said the road allow cars. It allows informations to pass through, to travel from one city to another city. So instead of cars, the internet moved text, it moved pictures, it moved videos, and it moved messages instead of what? Instead of cars. So our cars is our information. Can you get that? So let's look at this now. How does information move on the internet? How does it move? What do you think? How does it move? So, when you send a message or open a website now, your information is chopped into tiny packets. Packets are like, let's say, they're like puzzle pieces that are breaking down into smaller pieces. So these packets travel across different routes. It travels across different roads, different cities until it reach its final destination where they are put back together. So information doesn't travel as one big piece. It is always broken down into tiny packets, like just as we said, like puzzle pieces now. So each packet contains different things. It contains the sender address, that is where the address is coming from, where the information is coming from. Your packet carries the sender address, the receiver address, that is where it is going to, where our information is going to. So each packet, it has the sender address, that is where the information is coming from, the receiver address, where it is going to, and the data itself. Because now you have the sender, you have the receiver, where it's coming from and where it's going. What are they sending? What are they receiving? What are they sending? Is the data itself. So the data itself can include photo, can include text, can include videos, etc. It can include anything the internet carries. So packets may travel across different routes, different roads, but they all reach a destination. Like now, you are going to your school in the morning. So from you leaving your house, you cannot just stop on the main road. You have to reach your what, your destination. That is what also packets means. Because packets, they travel across different routes. Because let's say now, I'm going to the market. Leaving your house, you will get to your junction. You probably borrow a bike, stop at the market, then you start trekking to where you are going to get. Maybe you are going to get a tomato. So you have to trek. Maybe you're inside the market, you have to trek to your final what? Your final destination. So until they reach the final destination and they what? They reassembled back. So sending a, like when you are sending a book of mail in different envelope, so the receiver put them what? It's put them back together. So still following. So okay, I think okay, we are still on how the internet works. So I have some other things I actually jotted down on how. Yeah, so we're following this. So the third point, how do they talk to each other and the protocol involved? This, I'm talking about this now. How does the information, how does the network talk to each other and the protocol involved? So computer follow rules. There is a rule guiding our computer. And what those rules that are guiding our computer are called protocol. We know protocol are set of rules, and our computer they follow those rules, which are the what our computer follow this protocol. So the most important are the IP, the most important protocol are the IP, which is what internet protocol. Let me look for a way to so we said computers like the most important protocols is the what is the IP, is our what is our IP, that is our IP, is our IP. So what is the full meaning of our IP? IP means, what is wrong? So we said our IP means internet. IP means internet protocol. That's the meaning of our IP. Then it's also one of the most important protocol is also what? Is also TCP. Let me write that down also. TCP. So the meaning of our TCP is what? Transmission. Transmission control protocol. Try and build this. So we have the internet protocol and the transmission control protocol. Those these are the protocols that the computer rules follows. So let's try and know this. Without these rules, computer will not just understand each other. So IP give every device an address. Like now in your area, let's say that we are living in Ilutedo. Each area, like no, let's say you are living in Ogun State. Ogun State has different areas. So each area has an address with a unique house number. So our IP address is our what? Our IP address, our internet protocol gives every devices an address like a house number. The TCP make sure all the packets arrive safely in the right order. Like it can be from the ascending order to from the right to the top, from zero to the last number, from the beginning to the end. Like it must be arranged safely in the right order. Not that as you're sending the packets, one of the packets like was not really following. So TCP makes sure that all the packets it arrives safely. It arrives sure. It arrives safely. So let's go back to our also let's look at this. Let's think of our computer and our network as people speaking in a common language. So the language is made up of rules. I've said it before, which are called what? Protocol. What did I call it? They are called protocol. Let me try and put it in my slide. They are called protocol. They are called protocol. So said each of these rules are called protocol. So the important protocol that the computer follow is the what? Is the IP and the TCP. So this protocol, they make sure that every computer can understand and share information correctly. So let's go to the next aspect. What is the relationship between packets. What is the relationship between packets, router, and the four question? So after okay, let's go ahead. What is the relationship between packet, router, and reliability? Packets, router, and reliability. So I'll be explaining this in the aspect of a postcard story. So for instance, let's imagine our packets to be a postcard. So big messages, a photo or a web page are like are split into small photo card or postcard, sorry. Each postcard has a destination address, that is where you are sending the message to. So in a term of in the computer terms, our destination address is about what? Is our IP address, which is our internet protocol. From the beginning, when we are looking at this step theory, we said computer follows rules known as the protocol, and our protocol is follow two different aspects, the IP and the TCP. You say our IP, if for instance, is just as is your receiver address. So I mean, is our destination address. That is also our receiver address. So the destination address is the IP. So it contains the destination address, the page number, so that they can be reordered back. So when the person, assuming the person is going through the messages, so if it is numbered, you will be able to rearrange it back. So the purpose of the page number is for it to be reordered back. So and the postcard also contains a checksum. It's just like a little small check, which is our checksum. That is, it's the reason why there is a checksum is for you to spot damage. So let's go to we are done with the analysis of a packet. So let's go to the route. So mind you, we are still using the aspect of a postcard. So our router will be analyzing our router to be post office. So a router doesn't really read your message. It only look at the address you are sending the message to and forward each postcard towards the destination. Like now, I needed because let's check in our early days. Basically, there's no phone, so you have to go to post office to send your message to the destination you want it to. So they don't really check the content of the message. All they need is to look at the address of where you're sending the letter or the message to and forward each postcard toward the destination. You get. So it may choose different road or different paths for different postcard, because somebody may be sending it to Lagos, another person may be sending it to Ibadan, another may be sending it to Abuja. So and these roads are not one way, so there are different ways, so you have to choose a different path for each postcard. That's basically what router is in the aspect of the post office. So let's go to the third aspect, which is what the reliability. So let's look at this analogy. Did all the postcards actually arrived there safely? Was it unbroken? Was it in order? That is the aspect of what reliability in the aspect of our postcard. Your when you took those messages there, like they are all in good condition. They are all in they are like their needs that are in good condition. Maybe you are sending a glass a glass, let's say a frame. So sending this card, these messages. So reliability works in the aspect that did the frame arrive there safely? Was it unbroken? Was it in order? That's the aspect of the reliability. So how packets make these things reliable? How does it? Let's look at the relationship. Small pieces are safer. Now, you're sending a postcard, a little postcard to your friend. You should be able to know that yes, because it is small. It's basically it cannot break. I think it should be in a safer in a safer aspect. So small pieces are safer. If one packet is lost, you only need to resend that tiny pieces, not the whole file. Sure, you get like that. When you're sending a small pieces of data. So when one of the packet is lost, because it's small piece. So when a little is lost, you're not basically sending the whole packets back. You just have to be sending tiny pieces of data, not the whole file. So that's one of the aspects that makes packets reliable. The second aspect is what? Numbering and checks. Numbering and checks. Hope you are putting that down. So let me just jot something down for us. Let me jot something down. You said how packets how packets make things reliable for us. So we said the first is what? Small pieces. This is for those that, like maybe you want to really jot some things down. Small pieces are what? They are safer. They are safer. So let's go to the second is the second one, numbering plus check. So let's go to the third aspect. The third aspect should be I'll go back to explain this number and check. I just want us to be able to see this from our screen. Receipts. So we would be going for these three. So number one is small pieces are safer. Yeah. So this is basically it. Let me make it small because of the space. And I still want to have something to jot down. So yeah, we are good to go. So the first thing I already explained the reason why small pieces are safer. So the second one is what numbering and check. So a sequence of numberless receivers spot gap or duplicates. That's so that is one of the reasons why checksum what it catch corruption, it catch damages. So the third is the receipts and the retries. So with TCP, we said our TCP is our what transmission control protocol. The receiver actually send back. The receiver send back the that your notes. It send back. Um, what it to be sending back? It depends on what you save it. You can save it as I got your messages. I got it. Thank you for sending. It's it's send back notes. So if the receiver does not get the note in time, we our note is what we put here, the ACK. So if it does not get the ACK in time, it will resend back the packets. It will resend it. Assuming the ACK was able, the sender was able to get the ACK in time, you will be seeing a message as got it. Thanks for this. You will see a message pop up. But if the receiver does not get the ACK in time, it will send back the data, the packets. So this end-to-end dance is the core internet reliability. It is reliable because if you are not getting your message, it will basically send it back. Do you understand? So no ACK or no retry with UDP. What is UDP? That's the user data packet, I think. I'm not really sure. So the UDP is used for live calls and gaming. So it is faster, but also it's also less reliable. So how does our router? We just finished talking about how the packets. So let's look at how router affects reliability. Number one, path choice and rerouting. Let's look at that. If it's break or is crowded, too much of load is on the link, router can it can steer later packets around the problem. So multiple possible road is equals to resilience. So the second aspect is queue and drop. Router have waiting lines. Our waiting lines in router that are called buffers. So when they fill up, late packets they are dropped. They are dropped. So drop aren't actually bad themselves. So what can lead to this drop is network failure can lead to this drop. So it doesn't necessarily mean that the drop they are bad by themselves. So TCP, our transmission control protocol, it notices it. It noticed the dropped packet and it will resend it. So that is the work of our TCP in queues and drop. But too many drop can cause slowness. It can cause slowness. So the third aspect we'll be looking at is best effort only. A single router does not really guarantee delivery. The internet as a whole is a best effort. So reliability mainly comes from the endpoint, which is your device, and the server. That's your endpoint. So The reliability comes from the endpoint using what? Our TCP and our smart app. So, what is packets again? Packets are what? I don't think I've explained packets in terms of, okay, let me do them. Packets are tiny numbered pieces that what? That can be checked and resent back. What is router? Router, let me go back to the packets. Packets are tiny numbered pieces that can be checked and what? And resent. What is router? Router are traffic directors that pick paths and sometimes they drop packets when busy. Reliability. Reliability are mostly achieved by what? Transmission control protocol at the end. Using what? Using acknowledgements, ordering, checks, and retries. So these are the 4 points the reliability mostly use. So while router provide multiple paths and the what? They recover back from failure. Okay, so let's go to wire, cable, and network. So this, I'll be going through this. So the information on the internet, it moves from one computer to another in the form of bits over various mediums, including the internet cable, the fiber optic cable, and what? Wireless signal, that is the radio wave. So let me quickly walk you through the analogy of this wire, cable, and Wi-Fi. What does each of it means actually? So, okay. Let me say something quickly. How information travels through the internet? How do you think the information? How does it travel through the internet? So when you send a message, or you stream a video, or you open a website, so the information has to physically move between what? Between computers. So it travels by bits. Information travels by bits, which is the one and is zero. So tiny electrical pulses or light signal. So there are three main ways this movement actually happens. The first, through what? Our Ethernet cable or Ethernet cable, sorry. Through our Ethernet cable, which is what? Our Ethernet cable is always in copper wire. So these are the cable you plug into your computer or router. The cable you use or you plug with your computer, that is our copper wire, which is our what? Our Ethernet cable. So they carry electric signal that represents one and zero. That's basically the language the computer understand. So they are commonly used at home, at offices, and school. So let's look at the advantages of the Ethernet cable. They are fast and they are stable. They are not affected by wall or distance. Mostly they are secured. So it's really hard for an outsider to tap into it. Disadvantages of the Ethernet cable. You need physical cable running around, not portable. The Ethernet cable are not portable, so your device have to stay plugged in. So we have our fiber optic. So instead of electricity, they use light signal inside a very thin glass strand. That is what? Fiber optic cable. So data travels at nearly speed of light. So let's go to Wi-Fi. Wi-Fi use radio wave instead of wires. So why our Wi-Fi doesn't use wire, it uses radio wave. Our Wi-Fi is what? Is wireless. So your phone, your laptop, or your tablet, they connect to a router wirelessly. now. So the router is still connected to the internet using what? Using cable, which is our the cable can either be our Ethernet or fiber what, but our Wi-Fi is what? Our Wi-Fi is wireless. So I think let's stop there for today. Thank you very much for following me to till the end. So, in our next aspect, we'll be looking at IP address and the what? DNS. Our DNS is what? Domain name system or domain name service. Then we'll go to packet routing. I don't know, I think we've talked about this packet routing. Yes, we've done packet routing and reliability. Oh, we've done that. Then we'll go to what? HTTP and HTML. So we have encryption and public keys, cybersecurity and crime. So thank you. Stay tuned for the next class. Bye.